Another episode of Butt Crack Cycles. We're doing some Ironhead work today, and we're doing some charging system diagnosis on a late model Ironhead Sportster, my 83, my little blue and cream, blue and white, whatever you want to call it, sporty that y'all see here on this channel so much. This bike is equipped with a Cycle Electric DGV5000. I think it's a 5000, maybe they call it a 500. I can never seem to remember their naming nomenclature. It doesn't matter. It's a Cycle Electric generator. This is actually the second Cycle Electric generator that's been on this bike. The first one was on it for God knows how long. It was on it for years and years and years. It went out on me probably 2 or 3 years ago, so I replaced it. And recently, I just completed a whole bunch of work on this bike, and I took the bike on a rather long test ride and ended up over at one of my friends' houses. We were having a cookout over there, and I got feeling sick, so I ended up leaving the bike over there at their house, and I came back the next morning to get the bike, and the battery was dead. I had to push start the thing, and then I rode it home, and it started kind of running crappy on me on the way home, and the reason for that is because it was losing voltage to the ignition system. So this whole episode is about diagnosing battery charging, not alternator, generator issues on an Ironhead Sportster with a Cycle Electric generator. So there's everybody's favorite rooster. I hope you find this episode informative or perhaps entertaining, and maybe it'll help you with your bike. So just open the door to the shop. Bike's right behind me. Let's get to work. Okay, so we've got our voltmeter hooked up to the bike, and we're gonna turn it on here. DC volts, and remember, a fully charged 12 volt DC battery is usually right around that, 12.6, 12.7. Like I said, this bike has been sitting on the battery charger basically for a week after it died on me there over at Courtney's house, and I unplugged the battery charger from it this morning, so it's had probably a good, I don't know, probably a good 5, maybe even 6 hours not on the charger. I wanted to make sure this did not have a top charge on it. Sometimes when you charge a battery, if you immediately take the battery charger off and test it, you'll get a false reading. So the next thing we're going to do is I'm going to leave the voltmeter hooked up to it, and we're going to go fuel on and wait a few seconds for the fuel to get down to the carburetor. While we do that, we'll come over here to the carburetor itself, and there it is. I'll turn our idle speed up just a hair. I've said this before on this channel, this bike doesn't have a choke, so I just use this adjustable idle speed screw on it when it's cold, and it actually seems like it does a pretty good job. Roll the key on, and we've dropped to 12.2, 12.1, 12. Yeah, just the lights on this bike pulls that battery down pretty hard. Go ignition on. Couple pumps on the accelerator, maybe one more for good luck. Down to 12.8 over here, and let's start her up. I shouldn't have touched the throttle. So what I'm going to do is just let this thing sit here and run at a high idle and see, does this battery voltage ever start coming back up. So just killed the bike with the ignition switch. We're gonna go master power off to kill the lights. And we can see that the battery voltage does start coming back up pretty quickly. There is one more thing that I want to do though. Cycle Electrics right on their website says that most of these older bikes that run this style generator don't charge very well just sitting at idle. And B, that obviously the electric starter really will pull the battery down, and it might take as long as 20 minutes of just like cruising riding before the generator really starts charging the battery. So the next thing I want to do is just go take this for a test ride. I'm gonna go ride 15 or 20 minutes on it and then come back, not cut it off, and throw the voltmeter back on it and see what kind of readings we are getting. And hopefully we should be seeing the generator trying to charge something at that point in time. And if it is, then all I need to do is just throw a battery in this thing. If it's not, then we've got some more troubleshooting to do, and maybe I buy a voltage regulator, maybe I buy a whole generator. I don't know. Let's find out though. All right, so Cycle Electric says, you know, on a lot of these charging systems, generator style, they don't charge well at idle, and to go run it around for, you know, 20 minutes after you started the bike to see what's going on in your charging system before you make any further diagnosis. So that's exactly what we're gonna do. In fact, I'm actually only gonna film a very short portion of this, really just the beginning and the end, and I'm gonna kill two birds with one stone. I had an idea for a moto vlog that I wanted to do, so I'm gonna use the meat and potatoes of this ride, make it a moto vlog. So I'll see y'all in about 20 minutes or so, maybe 30 depending on how I feel. Looks like it's gonna rain, but whatever, no big deal. All right, so GoPro died on the way home, or maybe just ran out of battery, doesn't really matter. But I've been riding for quite a while, 20 minutes or so, maybe more. You can get the voltmeter and see if I can do this one-handed. That might be better. Maybe the display's in there somewhat. 11.69, so we're losing voltage. Now I'm gonna go bring the idle up. So I've let the bike sit here overnight, and I left the battery charger on it just so we have a, you know, a good fresh battery for any testing that we're doing here today. And the next thing that I want to do is I've undone the battery lead from the output terminal of the generator, and I've got my voltmeter hooked into it or set to ohms. Hopefully you can see this on the camera, and we're just going to go to the positive battery terminal. We've got 4.6 ohms, which is maybe a little bit more resistance than I would like to see. I'd like to see more like 1 to 1.5 ohms on that circuit. There's a circuit breaker line between the output terminal of the generator and the positive battery terminal. So I'm gonna undo our battery cables, and we're gonna investigate this circuit a little bit more and see if we can find somewhere that has some high resistance. And we've got a couple other checks to do with this, with the voltmeter here, well, multimeter rather, before we condemn this generator. Okay, so this is the circuit breaker in question. I realize this probably is hard to see on camera, but there's a circuit breaker, resettable circuit breaker right here. It has this white little plastic cap on it and then green tape around it. And it has this red wire that I've got undone. This is what goes over to the battery itself. And so I'm gonna just check from the circuit breaker to the other side of that wire. You can see right there we're 8.5 ohms, which is excessive. I also just want to take a second and show that it's important to always test your test equipment. I've had this meter for quite some time, and these leads are pretty old. And I was checking some of these other circuit breakers off camera, just trying to see like what kind of resistance did one of these other breakers have across it to use as a reference point. And I was getting some weird readings, and so I was like, let me just check the meter itself and these leads. Look at all that resistance across this set of leads. I'm like, uh-oh. So, zoom out a little bit. This set of leads is at least 10 years old, probably closer to 12 years old. Thankfully, I have a brand new set. I always keep a spare. So I'll need to order another set of leads. We'll put these in, and we'll do the same exact thing. 1.5 ohms. That 30, 40, 50 ohms is not right. So I'm gonna go back through and retest everything we just tested with this new set of leads, and let's see what we come up with. And I'm gonna leave that original stuff in there just to show that you can sometimes get some erroneous readings if your test equipment is not working correctly. So make sure you test your test equipment. So I'm gonna go from the wire end that goes to the battery terminal to itself, to the same side of the circuit breaker that it's on. We've got 1 ohm. Now I'm going to go to the other side of that same breaker, again to the terminal, the wire that goes to the battery. Six-tenths of an ohm, 8/10 of an ohm. Kind of depends on how I'm holding the meter. Around 1 ohm. All right, so the next thing I want to do is just like I was talking about, check some of those other circuit breakers for like a reference. So this is our circuit breaker for the charging circuit. We're at 9/10 of an ohm, 1 ohm. Let's go right next door. If I can get my leads on it. Yeah, that breaker's got 2 ohms across it, so we're doing better there on the charging circuit. On 1.2. Yeah, I don't think we're really out of line on that. The 9/10 of an ohm across the circuit breaker really looks pretty good. And lastly, I'm going to go from the wire that goes to the output terminal of the generator all the way through the circuit breaker and all the way down to the wire, this red wire that goes over to the positive battery terminal. 1.1 ohms. So there is no excessive resistance in this circuit. This generator should be able to charge this battery perfectly fine. Those readings we got at the start of this video, those were all thanks to this set of junk leads that's now going in the trash. So, whoops, sorry, I didn't mean to kick the camera. Always test your test equipment. If you're not sure you're getting good readings, take a second if you're doing some continuity readings and some some ohm readings, and just touch your leads together, and there you go, 0.7 ohms. That's like what you should be seeing. So yeah, just a quick little lesson. All right, and the next thing that I want to do is just do a really quick parasitic draw test and just make sure there's nothing on this bike that's drawing this battery down. I don't think there's going to be, but what we need to do is we need to switch our voltmeter leads or multimeter leads. The COM stays there in the COM, and you see we were over here on volt, ohm, RPM, diode checker, temperature, and then these are your 2 amp ports on this particular meter, is Fluke 88. And what we need to do is, this is milliamps. We're going to ignore that one because it's only 400 milliamps fused, and we'll go over here to amps, 10 amps max fused, and hope we don't have more than a 10 amp current draw. So we'll move our red lead over there, and then we'll roll all the way over here to amps. And also, real quick, a lot of meters will do this if you have your voltmeter set, if you have your voltmeter leads in the wrong places. So if you have them set up to measure amperage in line, which is what we're doing right here, and you don't have the range switch set correctly over to amps, say you have it set to DC volts, goes crazy. Beep, 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 tells you lead. It's telling you you're in the wrong place. So we're gonna go to the unhooked positive battery cable, and then the other side of our meter is gonna go down there to the positive battery terminal. And you can see we're drawing 0.001 of an amp. So nothing in here is sucking this down really far. I am going to hook, I've got the generator unhooked right this second. So just to make sure we're testing the whole circuit and that the generator itself isn't a current draw, let's unhook this and hook the generator back up. Okay, so the generator is hooked back up, and then I've got the wire just held onto the battery terminal, and again, we're still at 0.001 amp, so essentially 0 current draw, which is perfect. So I wanted to take a second and just talk about what we would have done if we had found a parasitic draw. Obviously, if we had turned the headlights on, etc., then yes, we would have seen that amperage jump way up. Probably enough that we would have killed the fuse inside the meter, since it's only rated for 10 amps. But say you have like a 5 amp reading. It just means that you have 5 amps worth of draw in the system while everything is off. Radios are a really common thing to do this, and the way you diagnose this is just by going through and pulling fuses out one at a time. And when you remove the fuse for the offending circuit, that parasitic draw will drop off of your meter. You'll go from 5 amps to 0 amps, or a tenth of an amp, or whatever it might be. Obviously that wasn't the case here. You can do an amperage test to see, is there more amperage being desired by the bike as a whole than what the generator can put out. Obviously, if the generator can't make enough amps to run the headlights and the ignition, then it'll never make enough to actually charge the battery. You need a amp meter that's capable of reading like 50 amps or so to do that, and I don't have one of those right this second. So the next place I'm going to go is just looking at the voltage regulator and the generator itself, and I wouldn't be surprised if we find something burn up in there. This is the second Cycle Electric's DG5000 that has been on this bike in the last 3 years. The first one was on it forever, and it crapped out on me, and the second one isn't looking so good. So let's keep digging. Okay, so I've gotten the clamp loose from around the generator. Ignore how dirty this all is. I've gotten the rain and some mud and dirt yesterday. Anyways, you can see down in the brushes here, and the brushes are a little bit thinner than I would like them to be, but it looks like they're still touching the commutator. I don't get the warm and fuzzies about this though, because I can kind of smell what smells like electrical badness. But I'm gonna try and gently work this voltage regulator off the end of this thing. This clutch cable is right in the way, isn't it? I have no continuity between any of that. Let's check this other one. Okay, so we've got 1.5 ohms between the what is that, the L terminal. So the L terminal, which would be for I think that's for a tach drive, which obviously we're not using, goes to this little black one. And the B terminal, which is the white wire, comes over here to that terminal on the generator body. And there is no continuity between the B terminal and this terminal here inside of the generator body. And the wire itself looks like it's actually been a little bit burned. All right, so you see right here in this white wire, it's kind of brown right there, like maybe something has caught itself ablaze. And we're just gonna grab the meter again. Let me zoom the camera out a little bit so y'all get a little bit more of a wide view. And there you go. You see the meter on the camera now. And we'll clip one side of it to the white wire, and we'll clip the other side to take the nut off, clip it to the B terminal. 300 kilo ohms. That's ridiculous. Should be like 1 ohm or less. And we went to the L terminal just to make sure it's not shorted to that. It's not. A ton of resistance there. And the L terminal goes to that black wire, 1.5 ohms, which is about what we should expect. And then, just to continue our theme of earlier in the episode, we're going to test our test equipment. 1 ohm, which is fine. So I couldn't seem to get the wire pulled through, but I pried this little tin plate off, and like I said, you can see the brown there, and this is raised and has obvious signs of heat being in there, and it smells terrible. When I pop this tin cover off, you can even see on the back of the tin cover how hot it's been. So this voltage regulator has decided it wanted to crap the bed on us. So I guess I'll roll the dice and order just a voltage regulator. Hopefully the rest of the generator is okay. I bet that it is. Yeah. Awesome. Okay, so it's a couple days later, and we've got our new voltage regulator here. Shout out to Lowbrow Customs. I ordered this on Saturday. Today's Tuesday. It showed up in the mail yesterday evening, so from Saturday to Monday is all it took to get me this part. And yeah, they just always do a really good job at getting stuff to me quickly and usually having what I need at a good price. And a couple times I've had to talk to them on the phone about an order or questions or anything, they've always been easy to deal with. So yeah, just wanted to shout them out. They do not sponsor me in any way, shape, or form. I give them my money. They're not giving me parts for free or anything like that. That would be cool. I just always try and take a second and just be like, hey, if somebody's done me right, y'all deserve to hear about it. Anyways, let's go inside and put this on. All right, so our voltage regulator is on, and I've got the wire hooked back up, and we are hooked back up here at the battery. And so the next thing that we're gonna do is we're gonna do a voltage drop test on this. And I'm gonna sit down, put the camera on tripod, and just talk for a few minutes about what is a voltage drop test and why we're doing it, and then I'll show you all how to actually do it. Also, side note, the camera that I usually film with, I actually just sold. It's on its way to its new owner, and my new camera that I'm upgrading to is on its way to me, so I'm using my little handheld pocket camera. So if you're wondering why the quality of video in this sort of segment is less than or different than what I usually film, that's why, but the show must go on. Anyways, let's sit down and talk about voltage drop. Alright, so what we're going to do is a voltage drop test. And the reason for this is because we have been working with stranded insulated wire. You know, like this. And all it really takes inside a wire like this is just one tiny little piece of copper to still be connected all the way through the wire in the insulation for it to pass a continuity test. And it might give okay readings as far as resistance when you're measuring it with the ohm meter, and you think it's still good. And that's not enough though to actually run the appropriate amount of current in the circuit to do whatever work you're trying to do. So it's a good idea on a charging circuit especially to take a minute and just do a quick voltage drop test. So what is a voltage drop test? Well, we got to take a minute and step back and just talk about some DC electrical theory. Remember that voltage in a circuit or in a system is potential. Think about it as a cup of water, and right next to it you have another cup that's empty, and they're connected with a tube, and there's like a little gate in between. All of that water in the first cup is the voltage. It's the potential to do work in that system. When you remove the gate, the water is then free to flow through the tube into the other cup. It's flowing, that's current, and it's doing work. It's moving, it's filling up the other cup. And so what we're doing with the voltage drop test is measuring the potential difference between two places. For example, if we take our voltmeter and we measure across a battery, and we measure between the positive and the negative post, all of the voltage in the battery, this is a very rudimentary way of looking at it, is kind of stored in the positive side. It has all of the voltage, 12.6 volts. The negative side has none of the voltage, 0 volts. And so the difference between those two places in the circuit within that battery is 12.6 volts. There's 12.6 here, 0 over here, 12.6 minus 0 is 12.6. That's why if you take a wrench and you throw it across your battery terminals or your bike, you get sparks. You've pulled the gate out between those two cups of water, and the voltage, the water from one cup tries to flow to the other cup. Again, this is a very, very rudimentary, simple way of looking at it. And if there's anything I've learned in the last couple years of doing YouTube, someone's gonna tell me you didn't explain it right or all the way. And someone's gonna be pedantic know-it-all and say, well, actually, electron flow is backwards from conventional flow. In a DC circuit, electricity flows from the negative side to the positive. Yes, I know that. But in conventional DC electrical troubleshooting and the way we draw wiring diagrams in the automotive and obviously, you know, motorcycle world is conventional flow, positive to negative. So now that we kind of have that understanding of why you get 12.6 volts DC measuring across the battery, what should we see when we test across the charging circuit, going from the output terminal of the generator to the positive battery terminal on the battery? Well, remember, these are all in one circuit together, and voltage is the same at any point in this circuit. The potential, the voltage at the battery, and the potential, the voltage at the output terminal of the generator should be the same. You should have 12.6 at the generator and 12.6 at the battery. And so when we measure that difference of potential, remember difference is what we get from subtracting, 12.6 minus 12.6 is 0. So in a theoretically perfect system with no voltage drop, our meter should read 0. Now, this isn't always necessarily true in real life. You'll often find a voltage drop of a few tenths. I like to see no more than 3/10 of a voltage drop in a circuit, especially a charging circuit. I have seen some shop manuals that say you can have up to 8 or even 9/10 of a volt as acceptable voltage drop. I kind of disagree with that, and here's why. If the standing voltage of a 12 volt battery is 12.6 or 12.7, you need about 1 volt over that to actually be charging the battery. So around 13.8 or 14 volts is usually what most alternators, generators, stators, whatever, charge a DC automotive 12 volt battery at. So if you imagine that you have a generator charging 13.8 volts and you have 8/10 of a voltage drop, you're now only getting 13 volts actually charging to that battery. If the battery standing voltage is 12.7, you're only putting 0.3 of a volt into that battery because you have so much voltage drop in that system. Yes, you will charge the battery, but it will charge very slowly. If you take a lot of short trips, you might not charge the battery at all. And so that's why I think it's important for us to just take a minute and do a voltage drop test and make sure we don't have any excessive resistance at any of those wires or any of the contact points in the circuit, and make sure that we're not running the generator too hard or the voltage regulator too hard, and that that's not the reason that this voltage regulator fried. All right. I realize this was a lot of talking, it's a lot of theory, but I think it's important for people to understand what they're learning so they can apply it to their own lives and their own troubleshooting, instead of me just sitting here telling you, take your meter and put it here, and look for this number. If this number good, if that number bad. I don't know. I like to know what I'm doing and why I'm doing it and the theory behind it. If you don't know how it works, you can't fix it. Let's go fix it. Okay, so right now we have the voltmeter clipped to the positive side of the battery, and then I just clipped it to a primary volt, which is grounded, obviously. And so we're reading 12.79, because the difference in potential between the positive side of the battery and that volt down there is system voltage. It's all the voltage. If we unclip down here, though, and we move our lead to the output terminal of the generator, now what do we have? 0 volts. And that's because, like we talked about, sitting in our chair, the potential difference across the circuit should be 0. So that's great. That's exactly what we want to see. So we should be ready to start this thing now, and we should have a charging bike. The last thing we want to do is redo the voltage drop test with the bike running. And you can see we're under that 0.3 of a volt. This is fine. I also changed the range on the meter to get a little finer resolution. But even if we were back on the old 60 volt scale, you see we're still around 0.25, 0.27. So you want to do that with the bike running, the generator charging, lights on, and some sort of a load on the bike. And that's good, that's fine. There she goes. I'm gonna open the door to the shop and let it sit there at like a high idle for a few minutes. We'll go back and check it. And yeah, that's looking good already. You know, before, if you remember earlier in the episode, we cranked the thing up and it pulled the battery voltage down. The electric starter would pull the battery down to, you know, 12.15 or 12.2, and then it would sit there and run, and it would never make more than, I think, 12.16, if I'm remembering correctly, is the most we saw a couple days ago. Sitting out, and it wasn't sitting in the driveway, it was here in the shop. And then by the time I rode it, you know, 15 or 20 miles, we'd been running the bike entirely off the battery and really drawing it down. So I'm curious, even just with it sitting here, this just 2 minutes it's been running. Let's go see what it's making right this second. Okay, we'll wrap this one up sitting out here in the woods behind the shop. I hope you learned something from this episode and saw that with something so simple as just a regular voltmeter, obviously this one's kind of expensive and fancy, but you can use like a $35 or $40 Harbor Freight voltmeter, or multimeter rather, and get the same result. But I hope you saw that using just a simple tool like this, a little bit of knowledge of how DC circuits work, how charging systems work, and some simple DC troubleshooting skills, that you can go through a charging system on an old Harley and diagnose what exactly is wrong and fix it. I was able to save a little bit of money instead of just saying, oh, the generator's bad, and throwing an entire generator in it. I think one of those Cycle Electric generators right now is like close to 600 bucks, and I paid like $175 for that voltage regulator. So that's a win in my book. I really enjoy doing electrical troubleshooting. Some of y'all know this about me. My last real job before I quit 3.5 years ago to work for myself was at a cat dealership, and I worked there for, I don't know, like 6 or 7 years, and I was in a field service truck, and I was doing industrial generator sets. So yeah, I hope you enjoyed this episode. Hope you learned something. I think that this battery will probably be good to go for a little while. I had a lot of people write some comments on my last full-length video about this, and I also did like a short about having to push start the bike because the battery's dead. I had so many people be like, I guess you've never heard of a battery charger. The battery tender would fix that. A battery charger would fix that. You're supposed to charge the battery. Like, yeah, I understand that. The bike is supposed to charge the battery. Yes, batteries don't last worth a crap anymore. They don't make them near as good as they used to. And that battery is 3 years old. But I think with a proper working generator now, I'll probably be able to get another year out of that battery, I hope. Last thing, I still don't really know why that voltage regulator failed. I'm filming this July of 2025. I bought that voltage regulator in September of 2022, so it didn't even make it 3 years. And I haven't checked my mileage records on that bike for that time period. I'm gonna take an educated guess though and say 6,000 to 7,000 miles probably is what I put on that motorcycle in that time period. Obviously I have multiple bikes and I'm buying and selling bikes, so my riding mileage gets split amongst multiple motorcycles over the course of a year. But with that being said, I guess if you were someone who had a 40 or 50-year-old Harley and you only rode it 500 or 700 or 1,000 miles a year, and you got 6 or 8 years out of a voltage regulator, you'd probably be pretty happy. But someone like me who actually puts some miles on their bikes, I'm not putting crazy miles on my bikes, but a lot more than many people who have older Harleys do. Less than 3 years and less than 10,000 miles is like not very good to me. But oh well, at least we were able to diagnose it, fix it, and the fix was less than 200 bucks plus a little bit of time. All right, I'm gonna stop talking. Bye.